Alright, let's talk about infinite geometric series. First off, we need to know, can I sum it up? Because you can't always sum up a infinite geometric series. So for example, 1 plus 2 plus 4 plus 8 plus 16. This is something called, it is a diverging series. It's diverging, which means you can't sum it up. How do you tell if something's diverging? You look at the r, the ratio. If the absolute value of r is greater than or equal to 1, it's diverging. And it makes sense because look, this is going to get bigger and bigger, 16, 32, 64, 128. You're never going to be able to add it up. I say equal to 1 because think about this too. If it was equal to 1, let's say you had 2 plus 2 plus 2 plus 2 plus 2 plus dot dot dot, goes on forever and ever and ever, you're still not going to be able to add it up, even though the ratio is 1 here. Okay, on the other hand, if you have something like this, 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16, these numbers are getting smaller and smaller and smaller. So as you add them up for all time, you eventually will be able to add them up. These are called converging. Converging means we can sum them up. We can sum them up. The way to tell if something's converging, the absolute value of r is less than 1. See, it's getting smaller, 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 smaller. So let's just check. Let's make sure we can do this. Converging or diverging. Converging or diverging. So let's take a look here. 1 minus 1/3 plus 1/9 minus 1/27, blah blah blah, forever and ever. All we got is find r. Take this negative 1/3, divide it by 1, that's negative 1/3. That's my r. Since the absolute value of this, the absolute value of negative 1/3 is less than 1, I can see it's getting smaller, 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 smaller. Eventually this last number is going to get really, really close to 0. Really, really close to 0. So this is converging. I can sum it up. Part B, 4 plus 8 plus 16 plus 32 plus dot dot dot. I mean, you can already tell it's getting bigger and bigger and bigger. Our r equals 8 over 4, which is 2. The absolute value of 2 is greater than or equal to 1, which means this is diverging. So you won't be able to sum it up. Basically, find r. If it's less than 1, it's converging. If it's greater than or equal to 1, it's diverging. Excuse me. Now, with that in mind, so picture here, going back up here, here's the finite series formula. Finite series formula. What would happen then if the n turned into infinity? So let's say infinite, or let's say not even infinity. Let's say you have some huge number. It's getting really close to infinity here. So you'd have a sub 1, whatever it is, times 1 minus r to the n. And there's your n, right? So r, what is r? Remember, if it's an infinite series, you can only sum it if it's converging, which means that your r is less than 1. It's less than 1, so it's some kind of fraction. Let me just give a demonstration here. So if it's less than 1, let's say it's like 1/2. 1/2, and then your n, of course, is this 99999 business. All over 1 minus r. Let's keep the r there. What is this number going to be, this 1/2 to the 99999? It's going to be some really, really small number, close to 0. So what you're getting is a sub 1 times 1 minus some number that's almost 0 over 1 minus r, which means that 1 minus 0 is 1. You're just going to be left with a sub 1 times 1 over 1 minus r, which gives you a sub 1 over 1 minus r. And this is the infinite geometric series formula. If you go back to the first page, here we are. So infinite a sub 1 over 1 minus r. Again, we notice that there's no difference really except for just this 1 minus r to the n part. And we just saw it's because the r to the n approaches 0 as we get really, really big towards infinity, which means that the numerator just becomes a sub 1. So to finish up, let's evaluate some of these. Let's sum these up. Okay, part A. So you have 1 plus 1/2 plus 1/4 plus 1/8 plus blah 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 for all infinity. First off, is this converging let's see, our r equals, our r is 1/2. Right, that's less than 1, so it's converging, so we're okay. So let's see, our sum equals a sub 1, again, minus 1 minus over 1 minus r. So a sub 1 is 1 over 1 minus our r is 1/2. So 1 over 1 minus 1/2, so 2 over 2 minus 1 over 2 equals 1 over 1/2. Remember, 1 divided by 1/2 is the same as multiplying by the reciprocal, so we get 2. You sum them up for all time, you get 2. Part B, 3 minus 3/2 plus 3/4 minus 3/8 plus blah, 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 all the way for infinity. Again, let's see, make sure our r works here. What is our r? Let's take negative 3/2 divided by 3. Negative 3/2 divided by 3 is the same as multiplying by the reciprocal, 1/3, which gives me negative 1/2. There, okay. The absolute value of that is less than 1, so yes, this is converging. Absolute value is less than 1, so we can sum it up. So S equals a sub 1, which is 3 over 1 minus r. 1 minus r. R is negative 1/2. So we're going to get 3 over 1 plus 1/2. So 3 over, remember, 2 over 2 plus 1 over 2, we get 3 over 3/2. Remember, 3 over 3/2 is the same as 3 over 1 multiplied by the reciprocal of 3/2, which is 2/3. The 3's become equivalent forms of 1, so we're left with 2 over 1, or just 2. Oops, 2. Okay, finally, let's do 3 plus 6 plus 12 plus 24 plus blah, 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 all the way to infinity. Check your r. R equals 6 over 3. That's 2. Again, 2, absolute value of 2 is greater than or equal to 1. This is diverging, so we can't sum it. Again, converging only if r is less than 1. That's when you can add it up, and then you can use the formula to get what you need.